everyone. So today is our last lesson on the unit circle. It's part 3, and today we are going to evaluate trigonometric expressions. Continued, it's what we ended with in lesson 3.6, but today we're just practicing those skills, seeing how confident we are, and then we're going to extend beyond the first rotation in the unit circle. So first we have a warm-up. I usually give my students in class 15 minutes to complete this, and students finish in a variety of different times. Some finish quickly and some don't finish at all. It all depends on how confident you feel with this material. So pause the video and evaluate these 6 trig functions and using the unit circle method or the triangle method, depending on which one you like. And then what I want you to do after you've completed this exercise is to unpause the video and check your answers. So go ahead and pause the video now and complete these problems, and when you come back, you'll see the answers. Okay, so now it's time to check your answers. For number 1, you should have had negative square root of 3 over 2. Number 2, you should have had negative a half. 3 is 0. 4 is undefined. 5 is 2. And 6 is the square root of 2 over 2. So once you've checked your answers, what I want you to do is pause the video if you need to and correct your work. You can see that I've sketched each angle for you, and I've let you know what quadrant the terminal side is in, or if it's not in the interior, if it's at one of the 4 corners, I've given you that terminal point. And I've also drawn the triangles down here at the bottom that I used as my reference. So once you're done with that, again, pause the video if you need to, come back, and I want you to think about how you felt about the warm-up exercise. You're either on a scale of 1 to 5, a 1, where I don't know what I'm doing and I'm going to be here after school for extra help. Those are for the students in my class. If you are at a 1, then you may need to go back and watch some of those videos. Or you're number 5, give me a quiz right now, I'm ready to go, I feel really great with this material. The whole point of this lesson is to get you to a 5. So this is really just a built-in lesson to give us more practice. So that's what today is about, just getting you to a 5. All right, so now what we're going to do is we are going to evaluate some trig expressions where I'm extending beyond just one rotation in the unit circle. So I'm going to be using coterminal angles. So here, I want to evaluate tangent of 17 pi over 6. So first, I want to sketch 17 pi over 6 to see where I am. I do know, I can already tell the reference angle is going to be pi over 6. So that's going to be helpful whenever I'm evaluating if I'm using this triangle. I'm going to go ahead and sketch a triangle. If you're using a triangle method, you already know since pi over 6 is my reference angle and tangent is opposite over adjacent, you get 1 over the square root of 3, which will simplify to the square root of 3 over 3. So I already know the numerical value of this, but it could be positive or negative depending on what quadrant 17 pi over 6 lies in. So I need to do that. So let's take a look. 17/6, if I rewrite that, is a mixed number. I get 2, and then 5 is left over. So I get 2 and 5/6. So this means I've got 1 full rotation of 2 pi's, and then I need to go 5/6 of a pi. So you've got 1 pi, 2 pi, 5/6 of a pi. It's close to 1 pi, but not quite. So here is 17 pi over 6, and it should be coterminal with 5 pi over 6 on your unit circle, meaning they're going to have the same values, same values of the 6 trig functions. Goodness, that's hard to get out. Okay, so if you are using the triangle method, and you know all students take calculus, you know sine and cosecant are the only 2 that are positive in second quadrant, so I know these are negative. So tangent of 17 pi over 6 is negative square root of 3 over 3. If you're using the unit circle method, you would have gone straight to graphing this and said, where am I? You'd find that you're here. In your terminal point, you would have already memorized as negative square root of 3 over 2, positive a half. And then tangent of 17 pi over 6 is equal to sine over cosine, so you'd have 1/2 divided by negative square root of 3 over 2, which gives you that negative 1 over square root of 3, and then you'd rationalize your denominator if you're using the unit circle method and using the terminal point that's right here. Let's look at another example. All right, so here we are. I'm gonna get this a little bigger. So we want to evaluate cosine of 13 pi over 2. So since I see that 13 pi over 2, you know, it doesn't really have a reference angle per se. I know that I'm going to be landing at one of the four corners. So the question is which one? Let's see how many rotations I have. So when I take 13 halves, that is equal to 6.5. So 6 pi's is 3 rotations and then half a rotation. So when I graph this, I'm going 2, 4, 6.5. So I'm landing here 13 pi over 2 and pi over 2 are coterminal angles. So if I am evaluating cosine, I know cosine is the x value of this point. The x value is 0. The next question down here says, what about sine of 13 pi over 2? Well, sine is going to be the y value, so that's just 1. Cotangent is equal to cosine over sine, or 0 over 1, which would simplify to be 0. So I could do all 6 at 13 pi over 2 once I know where it lies and what that terminal point is. All right, let's do this next one. Tangent of 15 pi over 4. So if I have 15 pi over 4, I got to figure out where it is. So 4 is going to go into 15 3 times, and that would give me 12, and I've got 3 left over. So I've got 3 pi's and then 3/4 of a pi. If I'm sketching this angle, I'm going 1, 2, 3 pi's, and then 3/4 of a pi, which will get me here in quadrant 4. So in quadrant 4, remember your acronym. All students take calculus. Cosine and secant are the only two that are positive here in quadrant 4. So I know that my evaluation here, since I'm evaluating tangent, will be negative. Then I'm going to go to my triangle. I need to use the reference angle for 15 pi over 4. And the reference angle is going to be pi over 4. That'll be what's left for terminal side to x-axis. So I'm going to my 45, 45, 90 triangle. And when I evaluate tangent, you do opposite over adjacent, which is just 1 over 1, and 1 over 1 is just 1. So tangent of 15 pi over 4 is 1. And also from graphing this, hopefully you can see that 15 pi over 4 and 7 pi over 4 are coterminal angles. All right. One more example. So I want to evaluate secant of 14 pi over 3. So first I'm going to start out by sketching 14 pi over 3. 3 is going to go into 14 4 times with 2 left over. So 4 pi's would give me 2 full rotations. So I've got 1, 2, 3, 4 pi's, and then 2/3 of a pi. So I am here in quadrant 2. So I have all students take calculus. Since sine and cosecant are the only two that are positive in quadrant 2, and I'm evaluating secant, I know this is going to be negative. So this again is sine and cosecant are positive. All right, so now my reference angle is pi over 3 when I go terminal side to x-axis. If this right here is 2/3 of a pi, this is 1/3 of a pi. And so I need my 30, 60, 90 triangle. And I'm looking at this pi over 3 as my reference angle, of course. So secant's definition is going to be hypotenuse over adjacent. So I end up with 2 over 1 which is just 2. So secant of 14 pi over 3 is negative 2. And once we have this graph, hopefully we can see that 14 pi over 3 and 2 pi over 3 are coterminal angles. There we go. So I did all of these examples using the triangle method just because that's what I am more comfortable with, and that's what I think is faster for me. But if you're using the unit circle method, you of course used those terminal points on the unit circle, and we should have got the same answers. So now you're all ready to do problem set 3.7 to give you some more practice with this material. And that's the end of the unit circle. Next, we're going to use all this information to finally graph those 6 trig functions.